We're asked to find the density of sample C, which we're told has sunk to the bottom and come to rest on a scale which is measuring 1/3 times the actual weight of sample C. To find the density of sample C, we'll need to use Newton's second law, and we'll need to know how to find the buoyant force for an object that sinks to the bottom of a container. Three forces are acting on sample C, and they are gravity, the buoyant force, and also the normal force because sample C is in contact with the scale. Sample C is not moving, so we can write Newton's second law for sample C as the buoyant force plus the normal force minus gravity equals 0. We can then rewrite the normal force in terms of the scale reading, which is 1/3 times the mass of sample C times the acceleration due to gravity. We can then combine these two terms, and we see that the buoyant force minus 2/3 times the gravity force acting on sample C is equal to 0. Moving the 2/3 mcg term to the right-hand side, we then rewrite the buoyant force in terms of the density of water times the volume of the water displaced times the acceleration due to gravity. Then on this side, we rewrite the mass of sample C in terms of its density and its volume, and we can then cancel out the acceleration due to gravity on both sides of the equation. We then note that because sample C is fully submerged in the liquid, the volume of the water displaced is equal to the volume of sample C. Plugging in this relationship into the equation, we can then cancel the volume of sample C on both sides, and we see that the density of sample C is equal to 3/2 the density of water.